glowing network represents the continuous stream of data pulsing through an IoT system. To make that data useful, we need a way to monitor it, which is exactly what we are going to build today by assembling a complete, real-time IoT dashboard. We are going to construct this interface entirely from scratch. To ensure the application works perfectly before we ever touch a physical sensor, we will simulate the live data streams directly on our machines. Step 1 is preparing the workspace. Create a new dedicated folder on your computer. Open your command prompt, type code, space, dot, and press enter to launch Visual Studio Code. As you can see in this diagram, a modern web application relies on 3 distinct layers sliding together: HTML for the structure, CSS for the visual styling, and JavaScript for the interactive logic. Building and testing these 3 layers locally with simulated data allows us to isolate our code. This prevents us from chasing down complex connectivity bugs later on when we actually plug in the physical modules. We start with the structural layer, create a new file named index.html, and generate the basic HTML boilerplate. This sets up the head and body tags, where all our visible content will live. Inside the body tag, create a primary div element and assign it a class of dashboard. This acts as the main container to hold our entire layout. Within that dashboard container, we need to create 4 separate division cards. These will house our specific IoT modules: temperature, humidity, gas level, and a control button for an LED. Take a look at this map. These blank outlines represent identifier attributes, or IDs. They act like empty mailboxes waiting to receive specific data packets. To route our simulated data, we assign unique IDs to the paragraph tags inside each dashboard card. For the 4th card, instead of a paragraph tag waiting for data, we add a button. This provides a way to send reverse input from the dashboard back to our hardware. With the elements in place, use the Go Live extension in VS Code to launch a local server. Your browser will open, displaying the raw, unstyled text. You have to build a properly tagged, structurally sound skeleton like this first. Until data has designated containers to live in, applying visual layers or interactive behaviors is impossible. Now we move to the visual design. Create a second file in your folder and name it style.css. Before adding any design rules, you must link this new style sheet within the head tag of your HTML document. This tells the browser exactly where to find your styling instructions. Start by applying foundational design rules to the entire document body. Set a dark background color and adjust the text alignment so everything sits cleanly in the center of the screen. Next, target the dashboard and card classes. Use Flexbox to arrange the subsections side by side and apply borders, padding, and a box shadow to give each module a distinct physical card shape. By applying these CSS rules, we reduce the cognitive load for the end user. We've taken a dense top-to-bottom wall of text and organized it into a scannable interface where environmental states can be read instantly. The final phase of development requires us to add programmatic logic. Create a 3rd file named script.js. Back in your HTML file, add a script tag pointing to this new JavaScript file. Place this link at the very bottom of the body tag to ensure the entire visual structure loads before any logic executes. Open the JavaScript file and write a new function called Update Sensors. This function will be responsible for calculating and displaying our simulated hardware readings. This diagram illustrates what our function needs to do. Use math.floor and random methods to convert static baselines into a fluctuating wave of data. Using document.getElementById, our script routes these data points into the geometric containers we established in the HTML. Be highly meticulous here. The most common point of failure in this step is a mismatched spelling between the ID name in your script and the exact ID name in your HTML file. To keep the data flowing, apply a setInterval method to the bottom of the script. This forces the update function to loop continuously every few seconds, generating a consistent real-time data stream flowing directly into your dashboard. Finally, write a separate function for the LED control. We attach an on-click event to the button that triggers a system alert, confirming that the user command was successfully recognized by the system. Programmatic logic acts as the system's nervous system. It bridges the gap between static user interfaces and live environmental hardware, allowing data to flow smoothly in both directions. With all 3 layers connected, navigate back to your full-screen browser and execute a final refresh to evaluate the completed project. If the code is correct, you will immediately see your temperature, humidity, and gas metrics updating automatically at the interval you set. Test the interactive component next. Clicking the LED control button should successfully trigger the browser's system pop-up alert, proving the reverse input functions correctly. To integrate this software with physical hardware, your next step is simply to replace the random math simulations in your JavaScript with actual network API calls pointing directly to your real sensors. Mastering front-end simulation isolates your interface variables. By completing these steps, you ensure your web application is fully stable and responsive long before the first piece of physical hardware is ever plugged in.